Hi AP Calc kids. Today we're going to review some stuff on inverses. So I'm going to start by a basic review of inverses, and then I'll go into the inverses, two special ones for this chapter. So in order to have an inverse, you have to first start with a function, and your function has to be 1 to 1. 1 to 1 means that for every x there's one y, and for every y there's one x. Basically, if you were to graph the function, it has to pass both the vertical and horizontal line test. Now in that case, you're going to have for the first original function, the domain is called D, that's all of your x's. The range is called R, that's all of your y values. Now I'm going to introduce a new function G. Its domain is now going to be called R, and its range is going to be called D. Notice that the D and R switch places. D was for domain, and range was for R, and now they're switched. Now that new function G is going to be called the inverse function if basically G and F cancel each other. So you notice here if I do G of f of x, the G and F kind of cancel out and you're left with an x. And the same thing happens with the y. So you have y equals y. That's what inverse functions do. They cancel each other out. For example, square root and squared, they cancel each other. Now you'll notice here again that the domain and range switch. That's what happens in all inverse functions. The domain of the inverse is the range of the original, and the range of the inverse is the domain of the original. So again, the domain and range switch. Now, if you need to find an inverse, what you're going to do is switch x and y in the original given function, resolve for the new y value, and that new y value will be your inverse. So I'm going to show you how to do that in some examples. Sorry for the beeping, that's the autofocus. Okay, so let's go ahead and take this first example. I start with f of x equals 3x minus 5. And what I'll want to do is change that f of x to a y. And in order to find the inverse, you have to switch these two. So you're going to take the x and turn it into a y, and the y and turn it into an x. So you'll have x equals 3y minus 5. And now I need to get this y value by itself. So I'll go ahead and add 5 to both sides. So x plus 5 will now equal 3y, and I'll divide by 3. I'm just going to go up here for room. That tells me x plus 5 over 3 is the new y value. Now you can't necessarily write it as y because this function is y. You have to indicate that this answer is your inverse. So instead of writing y, we use inverse notation. And you've seen it already at the top over here, but we write it as f inverse of x. Now this -1 does not act as a power. It is the notation for inverse. So whenever you see a -1 up in the exponent next to this f, that does not mean reciprocal. It means inverse. So your solution for the inverse will be f inverse of x equals x plus 5 over 3. Let's do it for a little bit more complicated function. So in example 2, I give you x squared minus 3, which you should know is a parabola. Now they give you this condition that x is greater than or equal to 0. There's a reason for that. If you remember above, all the way at the top, I said that in order for you to have an inverse function, you need to be 1 to 1 first. That means your graph has to pass both the vertical and horizontal line test. So if I graph a parabola real quick over here, this is x squared minus 3. It'll be down here at -3. You'll notice it passes the vertical line test, so it is a function, but it does not pass the horizontal line test. You hit 2 times. So in order to make this 1 to 1, which makes it eligible to have an inverse, this information is the domain of the original function. So this is the domain of f. And that means you're going to pick only half of this parabola. If I want the greater than 0 half, that means I'm going to pick the positive half only of the parabola. So this is what I want to find the inverse of. The procedure is the same. I'm going to change f of x to a y, and then I'll switch x and y. And now I'll have to go ahead and solve for this y right here. So I'll add 3 to both sides. So x plus 3 equals y squared. Square rooting both sides to get the y by itself. You as the student are introducing the square root. Don't forget, that means you're going to need both plus and minus. So you have plus and minus the square root of x plus 3 equals y. And now you have to choose, is it the plus or the minus? Now remember, I said earlier the domain and range switch places. So that means your y values are switching places. That means for this problem, all the y values have to be greater than or equal to 0. So that's why you're going to pick the positive square root. If this up here had said less than or equal to 0, you'd be picking the negative square root. So your y now, which you actually have to write as f inverse, is going to be only the positive square root of x plus 3. So that's the basic procedure for finding an inverse by switching x and y. Now what we'll need to do is talk about the graph of inverse functions. Now I'm going to switch this up a little bit. Inverse functions are special because the graph of an inverse is just a reflection of the original over the line y equals x. So let's look at the graphs that we did in these examples. The first example, example 1, was 3x minus 5. So it had an intercept of negative 5 and a slope of 3. 1, 2, 3 over 1. So this is the graph of the original function for the first example. Now if I look at its inverse, which you can write as x over 3 plus 5/3 by doing the flying v, boop, boop, that'll be an intercept of 5/3, so about there, and then a slope of 1/3. 1, 2, 3. It's about there. I'm going to estimate it. And you can see that the line y equals x splits that right down the middle. I could take this, fold the paper, and flip that over. Now this is a lot easier to see with this parabola example. Remember I talked about up here how I only want the positive half of x squared minus 3. So if I go down to negative 3 and only draw the positive half of the parabola, that's f. Go back and label this one f inverse. Now this one you should know is a sideways parabola moved left 3. And it's the top half only. And I think you can see, do you like my piranha? Look. Piranha, that was me chomping. This inverse, I think you can now see the reflection over the line y equals x. So those are some basics on inverses. But in chapter 7, we're going to talk about two special inverses. So now you'll need the extra insert sheet on the two special inverse functions. So two special inverses in this chapter are exponents and logs. So this is going to be a review of all the pre-calc stuff on exponents and logs. You can convert from an exponent to a log by means of this relationship. Basically, if you have an exponential function, y equals any base to the letter x, you can make that equivalent to or change it into a log by moving the base over. Logs are equal to exponents, so the exponent goes all the way over here to pass the equal sign, and then the y that's left over goes on the inside of the log. So again, these are inverses of each other. So what you can do is, again, switch x and y like I did down here. Logarithms, again, are inverses of exponential functions. So let's review exponents, and I'll show you how to, over here, switch x and y in the equation to go ahead and get the inverse graph. So, exponential functions. Let's do it by a table. If I want you to graph y equals 2 to the x, and you should know what the graph of that looks like, but you can plug in negative 1. You do that right in a calculator if you want. You'll get 1/2. Anything to the 0 power is 1. Anything to the first power is itself. 2 squared is 4, and 2 cubed is 8. Again, I'm taking these x's, and I'm plugging them in up here for x. Now if I were to plot this, this is going to be negative 1, comma a half, 0, 1, 1, 2, 2, 4, and then 3, 8. And when I draw this and connect the dots, this is the graph of an exponential function, 2 to the x. It has a very special point. They all have the point 0, 1, and they all have the point 1, comma the base. So this is 1, comma 2 because the base is 2. So it's 1, comma b. It also has an asymptote at y equals 0. All of those have the same thing. Now, if I want to graph a log function, is the inverse of an exponent. again, remember the domain and range switch places. So the x's are now my y column over here, and my y's will become my x column over here. So I'm just going to recopy them. What I could also do is take these numbers and plug them in for the y and see what the x would be. It'll be 1/2, 1, 2, 4, and 8. So I'll go ahead and plot those. So I'm at 1/2, -1, 1, 0, 2, 1, 4, 2, and 8, 3. When I draw these and connect them, this will go on forever and ever in both directions, and this will now have a vertical asymptote because everything has to switch. And I think from here you guys can see that it's a reflection over the line y equals x. Once again, it's the same thing that happened in our other inverse problems. Just to put it in highlighter for you, here's the line y equals x. I'm going to go back over it with the blue marker so you can see it a little bit better. And there's the reflection of those two graphs. Again, they are symmetric about that line. So again, a logarithm is the inverse of an exponential. So let's take what we graphed and rewrite it as a log. This would be log, the base is 2, log is equal to the exponent, so that equals y, and then whatever's left is the inside. So what I graphed in red here is log base 2 of x. Now, all logs look the same, just like all exponentials look the same. This is the parent graph. You'll always have the point 1, 0, and you'll always have the point the base, comma 1. So this point corresponds to this one. That will always be there. And then this is the point base, comma 1. Now again, it's always going to have an asymptote at x is 0, and there is symmetry between these graphs. They're symmetric over the line y equals x. Now some other things you need to know about exponents and logs from pre-calc. First, you need to know the laws of exponents and the laws of logs. So for your laws of exponents, you need to know that when you multiply like bases, you add their exponents. Divide like bases, subtract their exponents. Power to a power, multiply the exponents. Anything to the 0 power is 1, and anything that's to a negative exponent, you flip it. Now these correspond to the laws of logs. If you have multiplication in a log, you can break it up over addition. If you have division, it breaks up into subtraction. If you have an exponent, that exponent comes to the front. This is a super helpful property of logs. The log, no matter what the base of 1, is always 0. And if you have an exponent here, you can again take that -1 and bring it to the front, or you can make it 1 over. So this negative comes to the front, which is where this negative comes from over here, or again, 1 over is the -1 exponent. We're going to work with all of these laws of exponents and logs in our problems, but I want to go over a couple of other things, so turn the page. If you look on this page, there are 2 special bases you need to know from pre-calc. The 2 special bases for logs are 10 and e. These are the ones that are on your calculator. You'll notice log is always with 10 caret, and ln is always with e caret. These again are the log and ln buttons on your calculator. Log base 10 is the common log. You won't write the base. It's just going to be log. When there is no base, you need to know it's base 10. Log base e is called the natural log. We write it as ln. So in all of the problems, whenever you see log and there's nothing by the tail of the g, that means it's base 10. And when you see ln, you need to know that that base is e. Now we'll go over some more things in class, but you also need to know that there are some facts about ln's, I'd make a note card out of these, that you're going to see in these problems all the time and they expect you to know for the AP exam. ln and e cancel each other. Remember, logs and exponents are inverses, so natural log and e go together, so they're going to cancel and they're 1. The ln of 1 is 0. The ln of 0 is no solution. It's undefined, so this is the 0 with a slash. And the ln of a negative number is also no solution. The inside of a log is called the argument. You can never have it be negative. You also can't have it be 0. So if either of these show up in a problem, you know something's wrong. But you will use the fact that the ln of e is 1 and the ln of 1 is 0 all the time in our problems. When you come to class next, we're going to work on inverses and use a lot of these rules for logs and exponents in some of our problems for derivatives and integrals. See you in class.